Hello everyone, I'm Varun, Assistant Professor, Department of Mathematics, SJB Institute of Technology. Continuing numerical method session. Today we'll be having session on the next aspect of numerical methods. We have already seen how to construct finite difference table. Okay. Today we'll be looking into forward difference and backward difference in the first stage, and various basic aspects of forward and backward differences by constructing a finite difference table. Okay, we will look into that element by element or term by term the moment we construct finite difference table. Okay, so at first we will check on the formal definition of forward differences, or forward difference in short. The first forward difference of f of x, denoted by yes, it is delta of f of x, is defined as delta f of x to be equal to f of x plus h minus f of x. Delta is called as forward difference operator. Okay, so we already know that interval length is always or usually denoted by h, right? So it obviously means that if I have some x value, x plus h or x naught plus h will give me x1. So if I have f of x naught plus h, it obviously means f of x1, which is equal to y1. Getting it? I have x1 plus h, it will give me x2. So one way or the other, it is difference between f of x1 minus f of x naught. Okay, or in the next stage it is f of x2 minus f of x1. And we all must know one thing, that y is denoted as f of x. With that logic, I can write this as y1 minus y0 or y2 minus y1. Continuing like this, it will be y3 minus y2, y4 minus y3, and so on. Something like, in general, it is something like yn minus 1. Okay. So this is about forward difference operator. In the next stage, we have backward differences. Just like your forward difference, we have the first backward difference of f of x denoted by, yes, here we have nabla or del operator, alright, del of f of x, and is defined as del of f of x is equal to f of x minus h, where del is backward difference operator. And quite obviously, if I have some x1, okay, now I can write that as x1 minus h will be x naught. So in forward difference, we considered the term from x naught. Over here, we will be starting with xn, right? Then comes xn minus 1, then xn minus 2. So the upward is backward. In the sense, from the last element, we will move till x1. I mean, if the series decreases, if the sequence decreases, sorry, it's not the series. If the sequence comes down, it turns out to be x2, x1, x0. So the approach is from the bottom of the table. So this is about backward difference, and in the forward difference, we will come from the top of the table. Right? So to understand forward and backward difference in a better way, we will directly get into the problem. It's very simple. So for that sake, I will just take the problem which we solved yesterday, construct a finite difference table. Of course, I feel you people remember this. In our last video, we have solved this problem, right? X is equal to 0, 1, 2, 3, 4, 5, 6, and y is 1, 3, 11, 31, 69, 131, 223. As the first step of this problem, we will directly construct the finite difference table. This is already done in my previous session, so I would leave this as an exercise to you people. Okay, the finite difference table which we have constructed is also acting like the forward difference table. Yes, I want you people to observe here. Earlier we first difference, second difference, third difference, fourth difference here. Okay, now that was giving me finite difference table. Now in the same table it has become, yes, delta y, delta square y. The second column is delta square y. The second column is delta square y. The third column delta cube y. And finally the fourth column is delta power 4 with y. And if it continues, it is delta phi, the order, it is representing order of the table. So delta phi y, delta 6y, and so on. Okay. Now, similarly, all these deltas will be replaced by del operators or the backward difference operator. The first column is the first backward difference, which is del y. The second column is second backward difference, which is del square y, del cube y, and del power 4 y. If it continues, it will be del power 5 y, and so on. Now, term wise, if I take into consideration, I hope everyone remembers this, which was done in the previous video, right? So, elements, like when you have been given a data set, we will consider the first term as x naught, and the corresponding y value is treated as y naught. And from the second value, it is x1, x2, x3, x4, x5, x6, and their corresponding values will be y1, y2, y3, y4, y5, y6. The last value of x is treated as xn and its corresponding value as yn. Now with this, of course, we have already constructed first forward difference column. Now what happens is the first term is taken as delta y naught. Okay, when I am talking about forward difference operator, we will mention the first difference. When I say first difference, it is difference between 3 and 1, which is 2, and that will be taken as y naught, delta y naught. Okay, the second difference is delta y1, the third difference is delta y2, fourth difference is delta y3, fifth is delta y4, and the last one is delta y5. It is also written as delta yn. Okay, the last term is either represented as delta y5 or delta yn. Okay, to elaborate a little, we have already know 3 minus 1, 2 is giving us delta y naught. 11 minus 3, which is 8, happens to be delta y1. 31 minus 11, which is 20, is delta y2. 69 minus 31, which is 38, is delta y3. 131 minus 69 is delta y4. And finally, 223 minus 131, which is 92, is delta y5. Or it can also be written as delta yn. Right? Okay? Yes. Now what we will do is, we will move on to the second column, where we will be getting second order forward differences. Okay? Over here, the difference between 8 and 2 is 6, and that will be treated as delta square y naught. 12 will be delta square y1. 18 is delta square y2. 24 is delta square y3. And finally, 30 will be delta square y4. Okay? To elaborate a little, 8 minus 2, 6 is delta square y naught. The first term, 20 minus 8, 12 will be delta square y1. 38 minus 20, 18 will be delta square y2. 62 minus 38, 24 will be delta cube y3. And finally, 92 minus 62, 30 will be delta square y4. Right? Yes, the problem doesn't stop here. Yes, of course, the last term is also taken as delta square yn. And as I told you, the problem doesn't stop here, it is continuing, right? The moment it continues, we'll have third order forward differences. And the same way, we are taking, of course, all the six. The first element as delta cube y naught, the second element as delta cube y1, the third element as delta cube y2, and finally the last term is delta cube y3 or delta cube yn. Okay? Similarly, yes, the fourth order, it is delta power 4 y naught, delta power 4 y1, delta power 4 y2, and of course delta power 4 yn. Right? So whatever logic we applied here to understand the concept of forward differences, it's the same logic we apply for analyzing or finding the backward difference table. So this is all about forward difference table, right? So in the next stage, as I told you, we'll have backward difference table. Once again, we are considering the finite difference table, wherein the way of denoting is changing. If you can observe a little, instead of having delta y naught, now I am having del y naught, del y1, del y2, del y3, del y4, and del yn. In the same way, in the second column, I have del square y naught, del square y1, del square y2, del square y3, del square yn, and in the third column, I have del cube y naught, del cube y1, del cube y2, del cube yn, right? And finally, I have del power 4 y naught, del power 4 y1, del power 4 yn. Okay? The basic requirement for either of them is a finite difference table. The moment you are good in constructing a finite difference table, converting it in terms of forward difference and backward difference involves a very small logic. Okay? So the basic requirement is constructing a finite difference table. Okay? That's all for the day. Thank you very much for your patience. And few assignments will be posted in the group. Make sure everyone solves it. Right? Thank you.